After my last few videos, I kind of ran into a whole bunch of problems that resulted in project going on a bit of a back burner. And what happened was, I actually made quite a number of wrong assumptions about how circuits like this worked, and eventually found that the RMS conversion circuitry would not work because the current waveform on that mains line was not a sine wave. It was in fact some sort of distorted wave. Eventually, I had to rebuild the whole thing from scratch up, and from ground up, and that was the reason why there were no videos. So I'll show you what I've done. Let me take out the power from this thing now. Basically, I've rebuilt the whole kit, and you can see that the power supply, let me just get something to point here. So I have two voltage regulators now. I've separated the voltage regulator, the 5-volt rail for the ESP8266 from that for the analog section. And some of you may remember in my past videos I had problems with the with the noise, trying to get the noise down, and there were loads and loads of capacitors I put everywhere. Now this does the work so much better. I should have done this in the first place, but I've got a couple of regulators here, and this one is a 1117 LM1117. No, this one is the 1117. This one is a LM2937 or something like that. In any case, I've got two separate rails. One of them powers the RTC. This is the clock, this clock module, and a battery is supposed to go in here. I'm not sure if you can see it, but battery goes here. And this one is the 8266, and then I've got that ADS 1115 ADC module that I picked up from Banggood, and that seemed to work okay with this current setup. And what I did differently this time is I have this op-amp here that basically converts. It's like almost like an ideal rectifier that converts the sine wave into a positive only cycle, and then that feeds into these two carrier boards. And what this is an LTC 1966, I think it is. It's a RMS to DC converter. This is the thing that I should have done in the first place. So these two chips now, what they do is that they convert the two channels, one for the voltage and one for the current. And I've got it mounted up in the board like that. I've got a couple components to make it a bit more modular. So the output from this ideal rectifier goes into this converter, the true RMS converter, and that in turn goes through some filtering. And I don't think you can see it, but I've got some really tiny components around here. That's actually a 22 microhenry inductor, so it goes into one microfarad capacitor, and then the inductor, and then another capacitor to smooth out the noise, and that produces a really clean output from this converter that goes into this, and this works really well. Okay, so basically I've got the whole thing here, and just a couple of other details that might be of some interest. I've got the nylon standoffs here because this mains powered, so stuff under here is mains, right? So this mains powered, so I've got that with plastic nylon screws as well. I've got this little enclosure where this clip-ons is how I get the power on this thing. So when I power up this thing, which is what I'm going to do now, I'm going to actually connect the power to this thing. Let's see if we can get it going. Okay. So you see the power come on the RTC, right? And then the voltage, there's a secondary tap of this transformer that actually feeds for the monitoring of the mains voltage. And then I have this little plug here that goes to my current sensor. So two channels going into this quad op-amp. It uses 2 op-amp per channel. And then the power comes on. You see, everything's powered up nicely. I had to do a couple of little things like pulling the I2C bus to positive. All right. So now I've got the whole board mounted back into the casing, into the box, with these black nylon screws. Really neat, but bought a whole bunch of them. along with the standoffs and the nuts. They're all nylon, so that there's no risk of shorting out anything on the strip boards. So you can see that I have I've connected this thing up. The red light comes on the real-time clock, so that's the RTC board. I need to put a battery in here as soon as I find where I left the coin cell battery. And then the ESP8266 has got this blinking light, which I actually modified a little bit to get the light going. Now I'm using this light to indicate sampling. So when it starts up, I'm going to hit the reset here. It comes on solid, and then it's waiting for the clock. It will pull the time from the RTC, failing which you'll get it from some sort of NTC server, and then you wait for 0 seconds. So once the clock reaches the turn of the minute at 0 seconds, it will start sampling, right? At which point of time the LED will start blinking, which tells me that it's already begun sampling. So that's a kind of neat way of telling me that this thing is alive and it's not hung up on some code. And every 10 seconds or so it will write data, and as you can see, start blinking there. So every 10 seconds it'll write data to the SQL server, and then I'll have to find a way of visualizing that data, which I might do in another video. I just really want to quickly wrap this up because this has been hanging around for a really long time unfinished, and I'm just wanting to bring some closure to this project so I can get on with other interesting and hopefully less protracted projects. Okay, that's all I have for this little quick update. I hope that's been interesting. If you would like to know more information, I've got other stuff here, some 3.5 mm jack for the current sensor, and I've got some of these clips here for the power. If you are interested to find out a bit more details or software or so on, you could just put something down in comments, and I'll see what I can do about it. Okay, thanks for following me through this project. I'll catch you all another time somewhere on the internet. See you guys.